Saw a video criticizing Plantinga's ontological argument for existence of God by a YouTuber, Rhino. Let's see what he got.
Alvin Plantinga's modal ontological argument is probably the best argument for the existence of God.
No, strong disagree. I find the "just look around you, man" argument to be infinitely more convincing than this one.
It uses the laws of modal logic and acts similar to a mathematical proof.
Except it's philosophy, not mathematics, so no matter how airtight you think you've got it, somebody somewhere will disagree. I don't see anyone disagreeing with 1 + 1 = 2, but say anything philosophical and I can find you a whole group of people who will insist that you are wrong.
So, Rhino chooses to debunk IP's claim of semblance to mathematical proof, not based on structure or function of the argument, but based on how some people perceive it. Just stopping and thinking for a fraction of a moment will give you reasons as to why people do not normally object to mathematical proofs. For one, because they do not directly affect their life. Whether God exists or not is at least of some consequence to human species personally, but not whether 1 + 1 = 2. Imagine if the knowledge of 1 + 1 = 2 did change something radical about the whole movement and its philosophy. Would not some people be against it? Maybe, maybe not. But unlike the conclusion of ontological argument, it is more or less inconsequential to a particular belief system. But does not finding that 1 + 1 is not equal to 2 change entirely the way the whole world works? Like stock markets, interest rates, free offers, monetary exchange, etc.? Well, no. And now we come to the second reason why there is no disagreement about mathematical proofs. Mathematics is a tool to keep a record of objects or even abstracts like time. Ancient man probably developed numbers in arithmetic. The operators just denote a simple procedure adopted, like 1 + 1 denoting keeping one sack of grain with another. Then counting them again, we arrive at a number, which we can call 2, 3 or 10. In fact, in binary notation, 1 + 1 = 10. Philosophical arguments or syllogisms are like mathematical proofs, because like mathematics, the conclusion is present in the premises, and no addition of new information, just mere discovery, takes place. There is no uncertainty in the conclusion, provided one agrees with the premises, in case of a valid syllogism. Then why there are disagreements in philosophy but not mathematics? Let's take a more complex mathematical proof than 1 + 1 = 2, which actually isn't a proof but mere notation, and see what's the reason. Let's conjure a simple proof of the statement. If a perpendicular from one line meets another line perpendicularly, then the lines are parallel, that is, they never intersect each other. Assuming two lines defined by y = ax + b and y = cx + d. The perpendicular, let it be defined by y = ex + f from the first meets the second at 90 degrees. Now for the proof. Just considering the intersection of first line and perpendicular, we know that a is equal to tan of angle between the first line and x-axis, which let us assume is alpha. By using a simple property of a triangle, that the sum of all angles of a triangle is equal to 180 degrees, we can find beta, which is equal to 90 degrees minus alpha. The angle that the perpendicular makes with the x-axis will be 90 degrees plus alpha, the tan of which turns out to be -1/a, using simple trigonometric relations. So -1/a is equals to e. Applying same on second line and perpendicular, we find that e is equals to -1/c. Hence, c is equals to a. Now solving the equation of two lines, putting value c = a in second equation and equating the two, we find that b = d. If b = d, then the two lines will be same, which goes against our assumption. For two distinct lines, there is no solution, which means there is no intersection. Hence, the lines are parallel. Phew, that's the simple proof. Now, why is this so believable? Well, it is because it does not require any external tests or observations. You can discover and verify this proof sitting at home. No empirical observation is needed. The addition of empirical experiments raise several more factors like validity and exhaustiveness of experiments, validity of senses, probability at which the result is to be considered significant, etc. In this case, you only have to agree with validity of classical logic, a definition of terms. Everything else is derived from these. Hence, the proof follows necessarily without any contingency. Plantinga's ontological argument is exactly like that. While other arguments for existence of God require experimental evidence to back up premises, such is not the case for this argument. In fact, it can be proved or disproved while sitting on a desk by anyone with a mind capable of grasping logic used in the argument. So where is the disagreement coming from? Do you remember my proof? It seemed airtight, right? Well, it was flawed. It only applied to Euclidean world, not to non-Euclidean world. For one, the property that I took, that sum of all angles of a triangle is equal to 180 degrees, does not apply in non-Euclidean space, a space like ours. Longitudes of Earth do intersect, though they are at right angles to equator. Why is this? Well, for many reasons. Firstly, our constructions were on a 2D plane, not a 3D world. If we map longitudes on a 2D plane, we can see that they curve and are not straight to be called a line, which goes against the very statement I presented. So what to do in this case? Well, some would argue that longitudes are not parallel and will just change the statement to include stricter conditions for what is parallel. Some would claim that it is parallel and insist on adding that statement only works in a Euclidean world. In either case, there was a disagreement, but it is addressed by adopting a convention. And the disagreement is not in proof itself but in definition of terms. Ontological argument, similarly, if valid, can only be disagreed on the basis of definition of terms. And indeed, if you discount the fallacious criticism, it is the only objection that stands against an ontological argument. There is a conception or misconception, to put more appropriately, that we do not disagree with mathematical proofs. We do disagree, and that disagreement is based on how we define the terms mentioned in premises, and whether each individual premise is true. Similarly, in philosophical syllogism, most of us would agree with validity of classical logic, but only disagree with definition of terms or validity of each individual premise. Ontological argument is just one step more closer to mathematical proofs, because like most mathematical proofs, no empirical observation or tests are needed to establish premises. Practically, aside from difference of domain, there is no difference between the two. But if we disagree over mathematical proofs, why we do not get to hear about it more often? Because mathematics is a tool and a human conception. At least pragmatically, we change the meaning of terms and premises according to convention, and without it impacting a group and its beliefs seriously, there is no reason for any disagreement or controversy. And if you still think that I am wrong about the last statement, check out Monty Hall problem and the controversy surrounding it. Trigger warning. You may find claims of sexism or actual sexism. The way you look at it, that is. Adios.